And the pass rate?
Okay, today we continue to learn about the waves in strings. Let's quickly recall what we did yesterday. So, that if we have string fixed at both ends, that is the longest standing wave that can form in that string. And if the length of the string is L, the wavelength will be equal, double this, will be 2L. The next possible standing wave can be like this. When we will have the so-called wave envelope. And those are nodes, and that is antinode, then node, and we have two antinode, and we have wavelengths equal 2L on 2. Then we can have next, we can have it like this.
Right, so is for the one with the two, like the second, no, the other one, is it not just wavelength equals L?
Yes, 2 and 2 cancels out. I intentionally leave in those two because we will see the pattern. That the possible standing wave, now we have node, A, antinodes, and we have that wavelength will be equal to L on 3. So possible, what does it mean possible standing wave? All other, we can create wave not with those wavelengths, but it will not be, it will cancel each other. When we will have one wave traveling from one direction and reflected from from the opposite end, they will cancel each other. So only if we will have the wavelength equal 2L divided by n, where n is a natural number, so 1, 2, 3, and so on. Only such waves with such wavelengths can form standing wave. And that what will be at which wavelengths string will oscillate if you would say plug the string on the guitar. It cannot create any wavelength, only certain wavelengths related to the length. And of course, these will correspond, the longest wavelengths correspond to the lowest frequency, which will denote F0, and it's called A, the first harmonic, or another name, fundamental frequency. Fundamental frequency. Then this one, as wavelength becomes twice shorter. What happens with the frequency compared to this one? How many times? Wavelength twice shorter. Frequency will become twice bigger. And it will be called second harmonic. This will be F3. What will be this frequency equal in terms of the fundamental?
3 times.
Because wavelength 3 times shorter, frequency will be 3 times higher. And
Why is
that
the
will
first
be,
one F0 but the second's F2?
it can be sometimes F1. Why F0? Because also it's all fundamental frequency. It's the lowest possible frequency
Like
for standing wave to form, to like underline its fundamental meaning.
Yeah.
Second harmonic, this will be third harmonic. So, for example, if the speed of the wave in the string, remember it's not a wave, it's not a sound wave in the air, so it will have different speed. let's say in certain wave, in certain spring, speed is, let's say 500 meters per second. And length of the string is, let's say, 80 centimeters, 0.8 meters. What will be the fundamental frequency? What will be the fundamental frequency for that string? First, what will be the wavelength?
1.6.
The longest wavelength that can be formed standing wave will be 1.6 meters. Now, how we can find the frequency?
500 over 1.6.
Frequency equals speed over wavelength, so equals 500 divided by 1.6. That will be equal, using calculators to divide, it will be something like 310, about 312,
312.5.
Yeah.
312.5. Best for, so
312.5 hertz. If this is a fundamental frequency, so the lowest frequency that that string can
these are
produce.
312.
If we have now I'll write down the set of frequencies, and you need to tell me which of them possible in that string. For example, let's say we have out of these three frequencies, which can be created in that by that string?
Which can? The
Yes.
first one, I think.
Because the condition is that frequency has to be whole number times fundamental
The
frequency.
937.5 hertz.
Yes, because this is 312.5 times 3. This is not a multiple.
No, that's half, so I'm not gonna.
And this is a half, but it has to be bigger because this is the lowest possible frequency. So answer is this, and which harmonic it will be?
Third.
Third harmonic, because we have 312.5 times 3. It will be third harmonic. That was when string fixed at both ends. Now let's consider situation when the string fixed at one end only.
Oh wow.
String fixed only at one end. The longest wave that can be, so we have node at one end and we have antinode on another. That is the longest wave that can make standing wave on that string if it's fixed at one end. So we will have, what fraction of the wavelength is that? Quarter. So we have that wavelength will be equal 4 times length of the string. What will be the next possible standing wave created? We must have node on one end and antinode on another. So next possible will be like this.
But
That's not half.
how is that like?
Wait, what? Oh,
That because we must have node on one end and antinode on another end. So each time we add node and antinode. To have the next possible configuration, to have node on one end and antinode on another end.
Why can't it be two nodes?
There's
Because I
two
want to
nodes.
explain.
What's the dotted
no.
line?
This
What's
is
the
not,
dotted-
this is a fixed.
No, but what's the dotted line underneath it? What is it?
It's just showing like
Endpoint
that
can't be an
the
antinode.
string oscillate between those
Okay.
positions.
Then, so the endpoint can't be a node. It has to be an antinode.
Has to be antinode, yes. So what will be in this? What fraction of the wave is that?
2 on 3, I think.
Is it
Is it
3 on
quarters?
4, maybe.
It is.
Other
This
way
is
back.
a 1/2,
Okay, 3 on 4.
and then another
3 on 4.
quarter, so it's 3/4.
Oh,
So we
that's
have,
right.
yeah, you're right. 3/4 of wavelengths equal L, so L will be equal, so wavelengths will be equal 4L on 3. If you continue a pattern and we add another node and antinode,
Oh, I'm so excited for this. Oh my God.
It's actually
So we
giving
got
me some already.
node.
It's annoying.
antinode, node, antinode, node, antinode. What will be wavelengths? What will be wavelengths for such?
4L and 5.
Will be 4L and 5. As you can see,
It's 2n plus 1.
as you can see, in this case, it's only odd harmonic can exist. So if we have, this is a fundamental frequency of first harmonic, then we have the third harmonic will exist equal 3F0, then can be fifth harmonic exists equal 5F0. So in the string, which fixed at one end, only odd harmonic can exist. And the formula, general formula for wavelengths will be equal lambda equal 4L divided by, that is 2N
Plus
minus 1.
1. Oh, minus.
How are your notes like always notes in the middle of my notes? now?
Going to next harmonic, we always add one node, one antinode. Make sense?
Yeah.
Okay, that's pretty much all about the waves on the strings. And now we'll do some practice.